Greetings and welcome to my sabbatical research presentation on tidal power plant. Thanks for LCC for funding and sabbatical committee for approving my application. This sabbatical was quite enriching and useful for it generated some discussions among my colleagues as well as interested students who were fascinated by my research work and inquire more information about it. They were eager to learn and inspired to know more about this source of renewable energy. I also use the real field data into my classes in a form of group activity. Tides are formed by the gravitational pull of moon and sun on Earth. There are two high tides and two low tides, and tremendous amount of gravitational potential energy is available due to the displacement of water during the tides to be harnessed in a form of electrical and converted into electrical energy. For that, of course, we need a large basin and several hundred feet of barrage that separates the basin from the ocean and sluice gates that allows us to control the water flow. When both ocean and the basin is in high tides, we close the gates and we wait for the ocean to go to low tide. And then we open the gates and we allow the basin to empty itself over the turbines into the ocean and generate power in the ebb cycle. Then in the low tides, we close the gates and we allow the ocean to rise to high tide. And then we open the gates, and this time the ocean flows over the turbine into the basin and generates power in the flood cycle. It is quite challenging to select a suitable site for tidal power plants. So should you be interested, you can pause the video and read the criteria. Prior to my participation with the group, they had already checked out many satellite pictures and Google Earth maps to find a place in the northwest of the Persian Gulf, as shown in here, that there might be some potential for a tidal power plant site. There are hundreds of estuaries in here and body of water to be explored. Several days of studying is land and the estuaries and body of water and shipping traffic, and after several beautiful sunsets and seeing these exquisite mines and being tired, finally a site is being selected that might be promising. And this is in the form of a fork in here. Across from here is about a mile away. There is a shipping port that once the power is generated can be transmitted to there and connected to the grid. The surface of the water at different timing is shown in here. 300 feet of barrage would be constructed at this point, and the basin would be these two estuaries connected together. Hydrography starts by putting a GPS and sonar on the boat, and the boat will actually zigzag over the water and collecting the depth as well as the coordinates of points of the estuaries. And then afterwards, the GPS on the back of Masoud going around the perimeter will pick up a lot of coordinate points for the perimeter of the basin. I put together this data with their help, and the left estuary is about 2 mile long, and the right estuary is about 2,000 meter or about 1.25 miles. I picked up a few points along the length to see what the width and the depth is. The shape of the cross section is trapezoidal, and the depth does decrease as we move away from where the barrage would be constructed. All the data points that we have collected and map out to this, what you see in the computational technique that we applied, allowed us to see that the surface area available of water is about 360,000 square meter, and the volume of water available is about 2 million cubic meter. Putting all this data into this formula allowed us to calculate about 0.5 megawatt of power generated through an ebb cycle, and combined with the flood cycle makes it about 1 watt. This is even without considering frictional losses and efficiency of the turbines. This was quite disappointing because we hoped for tens of megawatts of power being generated, and now this seems to be not a cost-effective plant to be constructed here. Rather than abandoning the site, I suggested that we look at these estuaries that can be also combined to this, and maybe even pumping water from the back, and also monitoring the tidal range in the basin. That is to generate this graph that is the dashed line is the tidal activity in the ocean, and the solid line is what would be for the basin. And we need to have a good idea of the tidal activity in the basin. So therefore, we're going to construct some electronic devices to monitor the depth in here for several months. So Moving up to north, 1,100 miles away from our site, in the office, after a lot of discussions and a lot of designs and trial and error and testing, putting the hardware and software together. Here, the hardware will store the data and email it to us via modem. And software is working. We calibrated the device and now the sensors, and we are ready to take it down to south. On the way to south, we stop at this solar power plant that is 3/4 of the way done, and I actually participated in grounding system of this, as well as reducing the resistivity of the earth in the final phase of the power plant. On the way, we visited some landmarks, the oldest cypress tree in the world. And once we got to the site, we made the boat ready. And again, in the hotel, we put all the equipment together and mounted on this buoy. This buoy has 6 solar panels. A car battery would supply power to our electronic and sensors, and the solar panels will charge the battery during the time that the system is working. Everything is working and ready to take. On a foggy day, we take this to the site. And there, of course, we lower our sensors into the water and connect them to the motherboard in here. We anchor actually this buoy to the ground because this area can get flooded by high tides, and we are interested to see how many times there will be flooded and how high it gets, because that would mean more water available for the basin. Waiting for the high tides, reflecting on what we've done and checking out the local habitats. We have 3 days of data being emailed to us before we saw this error. We went back and sorted out the error. The preliminary data that I collected showed that there is a higher tidal range in the basin than we expected. That's a good news, actually, for higher power output. Saying farewell to our estuary and letting the data be collected for several months, we go back, and on the way back, we visit this valley of Eugene, which is very deep and very spooky. And the rest of this work is on the grounding of the solar power plant that I hope I will talk about that some other time. Thank you and goodbye.